In this video, we talk about the IEEE 802.1q VLAN chunking protocol. Let's get started with VLAN chunking protocols. As you may know, Cisco Switch has supported two different chunking protocols: the Cisco proprietary inter-switch link protocol and the industry standard IEEE 802.1q protocol. However, because the IEEE 802.1q protocol is so popular nowadays, many latest models of Cisco switch stop supporting the inter-switch link protocol. That is the reason why we only talk about the IEEE 802.1q protocol in this video. Now let's look into the detail of the IEEE 802.1q protocol. As you can see, this is an Ethernet frame. When the Ethernet frame comes to an 802.1q chunk port, it is inserted with an extra 4-byte 802.1q VLAN tag. However, only the 12-bit VLAN ID is used to identify VLAN. The 12-bit field supports to power up 12 or 4096 VLANs. In practice, Cisco Switch can support up to 4094 VLANs because VLAN 0 and VLAN 4095 are reserved. Cisco switches break the range of VLAN IDs into two ranges: normal range VLANs with the value from 1 to 1005, extended range VLANs with VLAN IDs from 1006 to 4094. The IEEE 802.1q protocol defines one special VLAN ID on each chunk as the native VLAN, defaulting to use VLAN 1. 802.1q does not add an 802.1q header to frames in the native VLAN. The receiving switch considers the frame without 802.1q header is part of the native VLAN. Because of this behavior, both switches must be configured with the same native VLAN. As you know, Cisco Switch forwards standard Ethernet frame in native VLAN over the chunk link, which allows it to communicate with a switch that does not understand 802.1q chunking. Also, no tagging will make Cisco Switch become more efficient when communicating via native VLAN. Let's analyze the results from a lab activity to have a better understanding of the IEEE 802.1q protocol. In the lab, we configure the network as in this diagram, with PC1 and PC3 in VLAN 10 and PC2 and PC4 in VLAN 20. Both VLAN 10 and VLAN 20 are not native VLAN. We then set up Wireshark capture on this link, and this link. Finally, from PC1, we ping the IP address of PC3, and here is the packet capture of the link from PC1 to Cisco Skill 1 switch. As you can see, the frame is a standard Ethernet frame. Here is the packet capture of the 802.1q chunk link from Cisco Skill 1 switch to Cisco Skill 2 switch. First of all, we must be aware that this is the Ethernet frame of non-native VLAN going across the 802.1q chunk link. Therefore, it is inserted with 802.1q VLAN header, and we can easily identify that the frame belongs to VLAN 10. Here is the packet capture of the link from Cisco you to switch to PC3. As you can see, the frame is a standard Ethernet frame.